to another episode of SQL Server or tutorial videos, this time about advanced topics in SQL area. We want to cover physical join operators, and for this purpose we now have a look at the simplest one. It is the nested loop join. So first of all, one could not say that any physical join operator, neither nested loop join, merge join or hash join, is particularly good or bad per se. They all have their advantages and disadvantages. So this is for sure the simplest one. So there are no prerequisites for a nested loop join. Nested loop join can be done basically on any kind of data set. Let's have a look at the algorithm though to understand how it actually works. So as I told you, the algorithm is actually the simplest one of all of the three ones, and thus the algorithm is also very easy to understand. So at first we take for each row we call from the outer table we call R1, take each row in the inner table calling R2, and then we check if R1 joins with R2. If it is the case, then we have our join, we output the row and we get the next row from the inner table. If it's not joined and we have a left outer join, then we output R1 and null as a tuple. So remember, the nested loop join takes for each row of the outer table, each row of the inner table, and compares if a join can happen or not. For this example, we join on the key customer ID. So have a look how the join will work actually. We start with customer ID 1 in the outer table, and then we work our way through the inner table on the left hand side. Whenever we join, like in this case, we add the row to the result. Now we finish with the first iteration of the join, so we switch now to the customer ID 2 and do the same thing all over again. And the last part is to do the last customer ID in the same manner. We go through, and whenever we join with the key, then we add the result to the table. So that's basically as simple as a nested loop join works. So based on the algorithm, you saw that the nested loop join can do an inner join and a left outer join easy. It can also do a left anti-semi join and a left semi join. But what we cannot do is a right join or any kind of right join. Since we have a nested loop on the outer and the inner table, we would have to preserve every inner table row to be sure in one kind of bitmap array or something like this, if we really had no join partner in the outer row at the end of the algorithm. But this is overload, of course, so it doesn't work with this. But what the optimizer does is that he transforms the right join, when he wants to do a nested loop join, into a left join by just switching out an inner table. It is possible, but it can be disadvantages because the optimizer of course tries to optimize always the inner table. So the costs of the join is, let's assume that the outer table has m rows and the inner table has n rows. Then of course, since we have a nested loop join and we scan all the inner rows for each of the outer row, then we have, of course, we have to multiply this, and when we are assuming that n is the bigger table, then we can say it is less or equal to n square in complexity. So this is actually very bad in comparison to the merge join, for instance, that is like 2 times n, which is a linear complexity, and here we have some quadratic complexity. So how does the optimizer try to optimize the nested loop join at its best? Basically there are 2 techniques. So overall you have to say the optimizer tries to minimize the I/O on the inner table, since the inner table is used every time for each outer row, and thus it tries to to put the inner table as the table that has an index on it. Also you can support the query optimizer by using an index on the inner table, because then you have only cheap seeks instead of whole scans all the time. Another technique is that the optimizer sometimes decides to spool, that means to save the results of the inner table, since they are always the same, of course, to not access them all the time again. So there are basically 2 techniques. The first is just using an index for the inner table, and the second is the optimizer spools the result of the inner table. So as I already told you, there are no right joins per se possible. It can be transformed to a left join. This is possible. There is a full join that is also not per se supported from a nested loop join, but the query optimizer can rewrite a full join to a left join. then a right join, which is also a left join, just transformed as I told you, and then a union all over it. Like you can see it like here. This would be the appropriate saying for join T1, table 1 with T2 full join. So it's possible. Also important is that a cross join is only doable as a nested loop join. Neither merge nor hash join can do any cross join. So since we covered now the theory of nested loop joins, let's jump into a few examples and have a look at those query optimizer, what he says, and to prove also the things that I said here. So let's jump right now into an example. We have the Northwind database here. If you don't know how to set up the Northwind database, please click on the left and you can see a video where I do it. In this example, we join the orders and the customer table on the customer ID. And we have also the city. We select only the rows where the customer city is London. Please be aware that the customer city has a non-clustered index on it. So the estimated simple execution plan looks like this. Like we have an index seek on both sides, and then we have a nested loop join here. Okay, but we actually want to have a closer look. So for a closer look, we set statistics profile on, and we get a textual plan here. I already extracted it into Notepad++ so that we can have a closer look here. So actually we have what we see here. We have a nested loop join with an outer reference. What is an outer reference? An outer reference on the customer table on the customer ID means that the seek on the inner table, that is the second seek here, this is the inner table, the seek is dependent on this customer ID. So as you can see here, the seek from the orders, that's why the O here, is dependent from the customer ID, and that's why it is here an outer reference. It is also called a correlated parameter. So we have a correlated parameter when an index seek is dependent on a certain column. This is actually an optimization technique that is very good. As you can see here, it's a simple two index seek and a nested loop join. It's really a perfect plan for us, and we can really benefit out of it. In the second example, we have a query that has no correlated parameter. That means there is no index seek in the inner table on which a column is reliant on. So you can see here in self join and on the employees table, and we select all employee IDs in this kind of manner. So as you can see here already in the estimated execution plan, that we have a two index scan. Since we have no on higher data there is no index, we cannot use a seek, and therefore we cannot use a correlated parameter, so we have to scan all of the clustered index. So let's have a look at the textual plan though. I prepared it already. We have here, as you can see, just no hint, nothing to be written here with the remark of outer reference. As you can see here you have the keyword outer reference. But in this query we don't have it since we have no correlated parameter. So we have just a where clause that is written here again, that is actually evaluated after the indexes objects are scanned, of course. So we have here a clustered index scan 2 times, and then the where condition is evaluated in the nested loop join on top of it. So I hope you saw the details between using a nested loop join when the inner table is able to use an index seek, because there is an index actually on the join key, and to be not to able to, so then the where clause cannot be pushed down to the scan operators or to the seek operators that cannot exist because there is no index, but instead it has to evaluate everything in the top level, which is of course more expensive then. I hope you enjoyed this video about nested loop joins. The upcoming video will be about the merge join, and then we will finalize the join series with the hash join. Please subscribe to my channel and spread the news to all of your friends and to guys learning SQL. Have a good day and bye.